Hello! Third video, second to last one of this little miniature trig unit. Today we're going to talk about how to find an angle if that's missing. So the last 2 days we've talked about how to find missing sides. First through Pythagorean theorem, second through using sine, cosine, tangent. And today we're going to talk about finding angles using sine, cosine, tangent as well. Process is a little different, but there's a lot of similarities. So as a quick warm-up, let's find the missing side of this right triangle. Let's reacclimate ourselves with some of the vocabulary. First of all, we want to figure out, since I have this 53-degree angle right here in this lower corner, I know that 16 is what we call the opposite leg, and I am trying to find the hypotenuse. So in this problem, I don't care about the adjacent leg at all. Opposite and hypotenuse are related using sine. And remember, anytime we're setting up a trig function, what goes in the parentheses has to be the angle. So make sure you put 53 in here, not 16. And then on the other side of the equal sign or other side of the equation will always be for sine opposite over hypotenuse, which in this case is 16 over x. At this point, I'm going to solve for x by first getting it out of the denominator. So I'm going to multiply both sides of the equation by x, which would give me x times sine of 53 equals 16. And then remember, I can divide. It seems weird, but I can actually divide by sine of 53 because the sine of a 53-degree angle is just a set decimal value. So sine of 53. So I'm going to divide both sides by sine 53, and I get x equals 16 over sine 53. And that's exactly how I'm going to type in the calculator, but you need to make sure that your calculator is in what's called degrees mode. On the TI calculators, there's usually a mode button, and then go down to the, in this case, for me, it's the fourth line. For some, it's the third, some it's the second. Make sure degree is highlighted, and if it's not, move over to degree and make sure you click enter. Click enter a couple times just to make sure. Then now I'm ready to type. 16 divided by sine of 53 is 20.034. For sides, I've been rounding to the hundredths place, so we'll just kind of keep with that same theme. 20.03. would be the length of the hypotenuse in this triangle. I mentioned it in the previous video. If I wanted to, now I could find the third side using Pythagorean theorem since I have the other two, but we're not worried about that. So just a very, very quick recap. Sine is opposite divided by hypotenuse. Cosine of an angle is adjacent over hypotenuse. And just a reminder that this symbol is called theta, and that just means an unknown angle. Sometimes you'll see x, but usually in trigonometry, we like to use something a little different to show that we're looking specifically for an angle. And so theta is often used. And then tangent is opposite divided by adjacent. So just a quick reminder of what the trig functions are and the two sides that they are relating. Okay. To find angles, we're going to do something that's brand new, but also very similar to things you've seen before. You already know how to solve an equation like this. If you have x squared equals 0.04, to get rid of the squared, I'm going to do the opposite of squaring, which is square rooting. And then that gives me x equals 0.2. Okay. So that, like, the opposite of squaring is to square root, and then they cancel each other out. 10 to the x equals 8.3. To get rid of, or to get x out of an exponent, you've already learned that I'm going to do log. I'm going to use logarithms. That's what we just got done learning. And then you would type this into the calculator. Log base 10 is already there. So x equals 0.919. So exponential and logarithms are inverses of each other. Here, if I want to know what angle has a sine value of 0.42, I can do what's called inverse sine. Okay. Now, on the calculator, right above sine, cosine, and tangent, for me, it's in blue. For you, it might be in yellow. It says sine -1. Okay. Now, what this does is if I were to take both sides of this equation, so this is read as sine inverse. So if I did that to both sides, okay, what would end up happening on the left side of the equation is the sine inverse and the sine would cancel each other out, and I would have x equals sine inverse of 0.42. Okay, so I'm going to use the second sine or the sine inverse function on the calculator. Now, if you're using inverse sine, the answer it gives you will be an angle. What you type in the parentheses is either a decimal or a fraction. In this case, I'm going to type 0.42 because that's the value I was given. And it says 24.8, which means x is equal to 24.8 degrees. Okay, so this is actually an angle measure that the calculator is telling me. This is saying, oh, hi, Miss Crandall. It's an A day. Sine of what angle equals 0.42? Sine of 24.8. And I can go ahead and check this. And sure enough, I get 0.4194, which is pretty close to 0.42. Okay, and this is the basis of what we're going to be doing today is we're going to be using what are called inverse trig functions, meaning the sine, cosine, or tangent with the -1 attached. Okay, so what this is asking is cosine of what angle? How many degrees would the angle have to be so the cosine is equal to 0.63? And to figure that out, all I'm going to do is type in inverse cosine of 0.63. It's kind of like how square rooting and squaring are inverses of each other. So 0.63 gives me 50.94. I'm just going to call it 50.9 degrees. That is the angle that I'm given. So that's the angle in which the cosine is equal to 0.63. I know I've said the same thing like 4 times, but reiterating it's very important. So here, tangent of theta, again, an unknown angle. Tangent of what angle would give me 3.6? So I'm going to say theta is equal to the inverse tangent of 3.6. So second tan, 3.6, and what the calculator will give me is an angle. So theta is 74.47, which would round to 74.5 degrees. In my experience, most of the time angles are written in terms in or rounded to the tenths. So I'm going to go with that today, but I understand if it was rounding to the thousandths or hundredths, you could do that as well. Okay, so inverse trig functions. We're going to use them a bunch in the next 3 slides. So here's how I can find an angle given some sides. So here, I have a triangle and I want to know how many degrees is that angle X right down there. Okay. I'm given 8 and 13. I know it's a right triangle, which is great because sine, cosine, and tangent, all this stuff we've been doing, the SOHCAHTOA only works in right triangles, which I didn't reiterate a lot, but it's true. I could find the third side of the triangle using Pythagorean theorem, but I don't need to. What I care about is that angle. So if I label the 8 and the 13, I see that this is my opposite leg because it's across. 13 is the hypotenuse because it's across from the 90. And so I don't have the adjacent, but again, I don't need the adjacent. I only need 2 sides to figure this out. So what I'm going to do is I'm going to set up a trig function using opposite and hypotenuse, which is sine. How this is different from yesterday is now the angle is what goes after sine, cosine, or tangent, and that is what I do not know. So I'm going to call it sine of x degrees. You could use theta, you could use whatever. Sine is always equal to the opposite leg divided by the hypotenuse. Okay. Now, instead of turning 8 divided by 13 into a decimal and then trying to round that, what I'm going to do is I'm going to use the inverse sign to tell me that in order to get x by itself, I need to do the inverse sign of 8 over 13. Okay, so I'm going to type that in exactly as it looks. So I'm going to do second sign, 8 divided by 13, and that will give me 37.97, which, if I'm rounding to the tenths, would be 38.0 degrees. Okay, so 38 degrees is the measure of angle X. Okay, so we've successfully found an angle using the two sides that we were given. And that's really what the basis of today's lesson is. I got two more examples. We're done. We'll move on. Okay. So here I'm trying to find angle theta. Always want to find the 90 because then that helps us to identify the hypotenuse. So the fact that I have the hypotenuse means I'm either going to use sine or cosine. If angle theta is what I'm looking for, that means that 10.2 is the adjacent, and adjacent and hypotenuse are related using cosine. So cosine of the angle theta, which is unknown, is equal to adjacent divided by hypotenuse, which means to find the angle, I'm going to use the inverse cosine of 10.2 over 17. Type that in exactly as it looks. Not times, divided by 17. 53.13, so 53.1 degrees. Okay, now I was not asked for this, 53.1. But what can be very quick is if you're asked to find all the angles in a triangle. Okay, we know that the one is 90, and I know that all three angles in a triangle have to add to 180. So I'm just going to subtract off 90 and subtract off the 53.1. And that would give me this third angle of 36.9. Again, I was not asked for that, but finding the third angle in a triangle is really easy because all you have to do is some very quick subtraction. Okay, so figure out the angle you have, figure out the two sides you have, figure out the angle you're looking for. What two sides do you have in regards to that angle that you're looking for? And then you can set up a trig function. So go ahead and give this one a try, and then we will be done here. Okay, so angle X is what I'm looking for. This is my opposite. This is my hypotenuse, which I don't care about or know. So that means I'm also using the adjacent, which is 2.8. Opposite and an adjacent are related using tangent. The angle always goes next, but I don't know the angle. Opposite is 5.2 divided by adjacent, which is 2.8. So I'm going to use the inverse tangent to find x degrees. And I'm just, again, you could divide 5.2 divided by 2.8 first, but just go ahead and type that whole fraction in, because what that'll do is prevent us from having to round too many times, and the more times you round, the less exact your answer is going to be. So we're going to go 5.2 divided by 2.8. Just misclicking all these buttons. 2.8. 61.6992443. So that is going to be 61.7 degrees. So 61.7 is the missing angle that we're looking for right there. Okay, and that's really, to summarize, how can I use the trig functions to find missing angles? Set up equation using sine, cosine, tangent. Then use inverse trig functions to solve for Missing angle. We did it.